Okay, so for this question here, it says complete the table, all right? And we need to convert each of these fractions to decimals, okay? So I'll show you how to do that now underneath here. And then we need to decide whether it's a recurring decimal or a terminating decimal, all right? And I'll explain that as well. So let's look at the first fraction here, right? 2 divided by 5, right? 2/5 there. So we'll change that to a decimal. Now, in order to change that to a decimal, you might know what it is straight away, but we could do the bus stop method and appreciate that we want to divide by 5. So that goes on the outside of the bus stop, all right? And then we'll put the 2 in here, okay? Now, 5, obviously it doesn't go into 2, doesn't it? So I'll put a 0 here because 5 doesn't go into 2. And we need to carry that 2. We need to move it across. There's nothing there, however. And if there's nothing there, you need to then obviously appreciate that this is a unit. So we put a decimal point there. And after the decimal point, if there's nothing there, we can put zeros, okay? You can put as many zeros as you want, right? But ultimately, because 5 didn't go into 2, I need to carry that 2. And I'll write it here then, okay, in the 10th column, right? And because I've placed a decimal point here, obviously then in the answer, we need to have a decimal point above. 5 then into 20, okay, we've got 20 there, and 5 goes into 20 4 times exactly, okay, all right, and we're done, right? So the answer is 0.4. We've got that as a decimal. Now let's keep going. Let's just change them all to decimals first. So let's do the next one, 5/8, right? So we need to divide by 8, all right? So again, the bus stop method, okay? So nice and big. Again, 8 won't divide into 5, so we put a 0 up here, okay? And we want to sort of carry, because we haven't used that 5, we want to carry it over. There's nothing there, so decimal point, right? Because there's a unit, decimal point, put a big 0 there. Okay, you can put as many zeros as you want, right? We could keep going like that. Sometimes that helps. But the 5 then that we carried, we'll write there. And then decimal point above, right? They're lined up. So then 8 into 50. We'll ask that question, does 8 go into 50? And it does. Okay, so you need to know your 8 times tables. And you realise that 8 goes into it 6 times. Okay, not exactly though, right? Because 6 times 8 is 48. Okay, 48. So it leaves a remainder of 2. So I'll write the 2 there, because there is a remainder. And I'll keep going. I'll do then 8 into 20. Okay, now 8 goes into 20. Of course, not perfectly, but it goes into it twice. And there's a remainder of 4, isn't there? Okay, okay, because 2 lots of 8 is 16, so there's 4 left over. And then 8 into 40 goes 5 times exactly. Okay, and we're done, because it does go into exactly, there's no more left. So 0.625. Okay, right, let's do the next 2. Right, 7/9. Right, so 7/9 divide by 9. Okay, so again, we have the same situation here. Maybe I'll put a few zeros this time, like this, because you see what happens now. Now 7 doesn't go into 9. Okay, oh, sorry, 9 doesn't go into 7. So we'll carry that 7. And then 9 into 70, we've got them. Now again, you need to know our tables. 9 goes into 70, okay, 7 times, right? Not exactly though, because 7 lots of 9 is 63. So 63 from 70 leaves us a remainder of 7. So I'll write 7 there. 9 then into 70, okay. Again, it's going to be the same thing, isn't it? 9 goes into 77 times, which gives me 63, remainder of 7. We're going to keep going like this, okay? It's going to keep going. 9 into 70 goes 7 times, 7 remainder, and so on. It just keeps on going forever, all right? So this is what we would call a recurring decimal, right? Or repeating decimal. It's recurring because we just got a string of 7s. So the way I can write this is put a dot above it to show that it repeats. So that's what it is as a decimal there, okay, with a dot above. Finally then, 2/11, okay, so we want to divide by 11 this time, and you'll see that we'll have something similar, okay. Again, we'll have a recurring decimal. So we put loads of zeros here. Okay, so 11 obviously doesn't go into 2, so we put a 0 there and carry the 2. 11 goes into 20 once, with remainder 9, okay. So that, if you think about it, 11 only goes into 20 once, remainder 9. 11 goes into 90. If you think about it, 8 times. And 8 times 11 is 88. So there's a remainder of 2. Okay? So then 11 then goes into 20 once, remainder of 9. And then 11 into 90 goes 8 times. So you can see now there's a sort of repeating pattern going on here again. Okay, so 11 goes into 90 8 times, and 8 times 11 is 88, so there's a remainder of 2. 11 into 20 then goes once, remainder of 9, and so on, right? It keeps going like that. So you can see 0.18, 18, 18. So the repeating pattern here is 0.18. The 18 keeps repeating. So what we do then is we put 2 dots there. A dot where the pattern starts and a dot where it ends. Okay, so you can see then it's 0.1, that's where it starts, 8 where it ends. So it'll be 0.18, 18, 18. We write that there. Now these are what we'd call recurring decimals, as we just discussed. These ones up here, though, do come to a stop. They don't keep going on, right? They stopped. So we call these terminating. Okay, if you think about terminator, terminator puts things to stop, right? The terminator stops things. So terminating means it comes to an end, all right? But these are recurring, okay, because they repeat like that.